So in section 5.3, we just solved various types of exponential and logarithmic equations. Okay? So this is strictly problem solving based upon what we already know from sections 5.1 and 5.2. So in example 1, right, given a bunch of exponential logarithmic equations. And so in A, we have the exponential equation 4 times e to the 2x power is equal to 5. Now you got to solve for x, right? What value of x makes the left-hand side equal to the right-hand side? Makes the left-hand side equal to 5. Well, this is 4 times e to the 2x. So we can divide both sides by 4. Right? We have to isolate the x on the left-hand side. And 4's cancel. We're left with e to the 2x is equal to 5/4. Now, on the left-hand side, the x is in the exponent. Okay. So we got to get rid of this e, so we just have 2x on the left-hand side. Well, property 3 from the natural logarithmic function says the natural log of e to the x, right, is just x. So here we have e to the 2x. So if we take the natural log of both sides, we have the natural log of e to the 2x on the left is equal to the natural log of 5/4 on the right. Okay. Now remember, when I write the natural log of e to the 2x, right, that's the same as the natural log of e to the 2x, right? Ln is the name of the function, e to the 2x is the input. Okay? But because ln, natural log, is a special name of the function, we often draw it in parentheses. So e to the 2x is the input to the natural log function. And based on property 3, ln and e cancel, and we're left with 2x is equal to 5/4. Excuse me, the natural log of 5/4. And so now you divide both sides by 2, or multiply both sides by 1/2. And we have x is equal to 1/2 times the natural log of 5/4. Any questions on that? In B, we have 2 to the x is equal to 10. Now the shorthand answer to this is, right, you know, 2, right, we have 2 is the base of this exponential, x is the exponent, and 10 is the value of the exponential. So, you know, from logarithms, this exponent x is equal to log base 2 of 10. This is the exponential statement. This is the logarithmic statement, right? We did that, right, in 5.2 on the first page, right? We had given an exponential statement, we had to rewrite it as a logarithmic statement. So the short answer is x is equal to log base 2 of 10. And a lot of calculators, now, on our exams are no calculator exams, right? So if we had calculator exams, you would have to try to give a decimal answer. Okay. So a lot of calculators, right? If you have to give a decimal answer, a lot of calculators these days, right, will do logs in any base. Okay. Now, like my calculator that I have that's 20, 30 years old doesn't do it in any base. I can only do logarithms in the natural logarithm and base 10. Those are the only two choices I have. So an alternative way of solving for x is to use the natural logarithm. Left-hand side equals the right-hand side. So I can make 2 to the x and 10 arguments inside the natural log function. Take the natural log of both sides. And then by the power rule of logarithms, I can bring this exponent x down in front of the natural log. And I have x times the natural log of 2 is equal to the natural log of 10. And now I divide both sides by the natural log of 2. And I get x is equal to the natural log of 10 over the natural log of 2. Using your calculator, log base 2 of 10 and the natural log of 10 divided by the natural log of 2 both have the same decimal value. They're the same have the same numerical value on the real number. Okay. And this comes from, you ever hear of the change of base formula? Change of base formula says log base 2 of 10 can be rewritten as the natural log of 10 divided by the natural log of 2. Okay. So have you ever heard of the change of base formula? Okay. You'll understand this in this answer. Okay. So there are two approaches, right, to solving a problem like this. All right. Any questions on that, ladies and gentlemen? Okay. All right, in C, this one's a little more involved. We have 2 to the x is equal to 7 raised to 3 plus x power. Okay. Right? So now the right-hand side is not equal to a real number, right? Where we can use, we got the variable x in both exponents on the left side and the right-hand side. And so to solve this, right, we're going to use the natural log function like we did over there. Okay. We're going to take the natural log of both sides. So we have natural log of 2 to the x is equal to the natural log of 7 raised to the 3 plus x power. Okay. And now you know by the power rule of logarithms, this x, right, can be brought down from the natural log of 2 like we did over there. So we have x times the natural log of 2. This 3 plus x can be brought down from the natural log of 7 by the power rule of logarithms. And now we have, right, we're solving for x. Okay. Now, over here, now natural log of 7 is a real number on the real number line. Okay. So you do type in natural log 7 in the calculator, you'll get a decimal value, right? A decimal value is where the natural log of 7 is on the real number line. So we treat the natural log of 7 just like you would the number 5 or the number 8. Okay. And so in solving for x, right, this is like the number 5 out here, you would distribute it inside the parentheses, right? So you can put all the x terms on the left-hand side of the equation and all the terms without x on the right-hand side. So we have x times the natural log of 2 is equal to 3 times the natural log of 7 plus x times the natural log of 7. Now I'm leaving the x in front of the natural log of 7, because if I put it after, we might think it's the natural log of 7 times x. It's not what it is. Okay. This is, right, a real, a real number, natural log of 7. So on the right hand side, we got one term without x, one term with x. On the left side, we have just this term with x. So let's move this term to the left hand side by subtraction. And so we have, when we subtract that term from both sides, we have x times the natural log of 2 minus x times the natural log of 7 is equal to 3 times the natural log of 7. And now you see on the left-hand side, x is a common factor in these two terms, right? So we can factor out the x, and we have x times the natural log of 2 minus the natural log of 7 is equal to 3 times the natural log of 7. Treating the natural log of 2 and natural log of 7 just like we would any other real number, right? Like 5, 8, 12, so forth. And now you see this is a product, right? But it does multiplication division. And so we're going to divide both sides by what's inside the parentheses. So we have x is equal to 3 times the natural log of 7 over the natural log of 2 minus the natural log of 7. And so that is the exact value of x that's put in for x in our original equation on both sides. The left-hand side equals the right-hand side. And then you can get a decimal value for x using your calculator. Okay. Any questions on that? All right, let's take a look at D. We have 2 times the natural log of 3x is equal to 4. So you notice that we got parentheses around 3x just to clarify things, right? That we're 3x is the argument going into the natural log function, not just 3. So left-hand side, right, we have a product. We can divide both sides by 2, right? We got to solve for x. That's the ultimate goal, right? What value of x makes the left-hand side equal to the right-hand side? So we divide both sides by 2. Twos cancel on the left, and we're left with the natural log of 3x is equal to 2. So x is in the argument of the natural log function, right? So to solve for x, we got to get rid of that ln. Well, property 4 of the natural log function says e raised to the natural log of x is just equal to x, because the natural exponential function and the natural log function are inverse functions of each other. Right? They undo each other, cancel each other, and we're just left with x. So we can make ln of 3x and 2 exponents on the number e, because they're equal. So we have e raised to the natural log of 3x is equal to e squared. Right? Now e squared is a real number on a real number line, right? Because e is equal to what, 2.718, and then you square that, right? So e squared is a real number on a real number line. And so by property 4, the natural log function, this is just equal to the argument going into the natural log function, which is equal to 3x. And this is equal to e squared. 3 times x, what undoes multiplication? Division. So we divide both sides by 3. 3's cancel on the left, and we're left with x is equal to e squared over 3. So that is the value of x that makes the left-hand side in our original equation equal to 4. Cool beans? All right, in E, we have to solve the logarithmic equation, the natural log of x minus 1 minus the natural log of x minus 3 is equal to 1. Well, riddle me this, ladies and gentlemen. So the first thing we're going to do is condense the left side. What property of logarithms do we use to condense the left side? Yes, sir.
Can we do the maybe the division one? I don't know which property that one was. Whenever they, yeah.
Which one is that?
2.
2. Quotient rule, right?
Quotient.
When you switch, we're going to switch the left and the right hand side. The log of u minus the log of v is the log of u over v. Right? So we can take this difference in natural logs and write it as the natural log of a fraction. Right? So this is equal to the natural log of x minus 1 over x minus 3. Okay. That's the quotient rule. Now, you got 2 x's in the argument going into the natural log function, right? So we got to get rid of the ln. How do we get rid of the ln? What undoes ln? The property 4 up here, right? Since left side is equal to right side, we can make the left side and the right side exponents on the number e. So we have e raised to the natural log of x minus 1 over x minus 3 is equal to e to the first power. Property 4 says e raised to the natural log of x is just x, right? Well, instead of x, we got this in parentheses. Okay. So we have the left-hand side just ends up being equal to the argument going into the natural log function, right? X minus 1 over x minus 3 is equal to 1. Now you got to solve for x, right? So we got x minus 1 divided by x minus 3. What undoes division? Multiplication, right? So we multiply both sides by x minus 3. X minus 3 is cancel on the left. And we're left with x minus 1 is equal to, oh, you guys let me get away with bad math. What's wrong?
Would it be e raised to the 1?
Yeah, it's e to the first power, right? It's e to the first power. I was looking at this and I was going to get no solution. Yeah, so this is e to the first power on the right hand side is just e. So e times x minus 3. So I have x minus 1 on the left. And now e, the first power, that's just a real number. That's 2.718, right? So we distribute the e inside the parentheses. We have ex. Now this isn't e to the x power. This is e to the first power times x. Okay? This is like 5 times x. Okay? E times, not e to the x power. Minus 3 times e. So I got 2 terms on the left, one with x, one without. 2 terms on the right, one with x, one without. So I got to bring this term, e times x, to the left-hand side by subtraction, and move the minus 1 to the right-hand side by addition. And I have x minus e times x is equal to 1 minus 3e. Well, on the left I got 2 terms involving x, where they each have x in them, so I can factor out an x. So x times 1 minus e is equal to 1 minus 3 times e. And now I divide both sides by 1 minus e, and I have x is equal to 1 minus 3 over 1 minus e. And we're done. So this is the exact value, right? So you can type this into your calculator, you'll get a decimal value. This is the exact value of x that makes the left-hand side over here equal to 1. Okay. Any questions on it? No questions? Okay. So let's take a look at f. We have the natural log of x minus 2 plus the natural log of 2x minus 3 is equal to 2 times the natural log of x. Now this is an interesting problem. Okay. Let's solve for x. Okay. All right. Well, we need to condense the left-hand side. Okay. How do we condense the left-hand side? What property do we use? You know? Product rule, right? The product rule says the natural log of u plus the natural log of v is equal to the natural log of u times v. Okay. So the left-hand side can be written as the natural log, I'm going to put this in brackets, of x minus 2 times 2x minus 3. Right? I put it in brackets so you know that the argument going into the natural log is that product. Okay. And on the right-hand side, this 2 can be made an exponent on the variable x. And so I have the natural log of x squared. Now, this is the argument going into the natural log on the right-hand side. So I have the natural log of this argument on the left is equal to the natural log of this argument on the right. Since the left side and right-hand side are equal, what must be true about the two arguments? They must be equal. Now I could use the number e and write this e raised to the natural log of what's in brackets here is equal to e raised to the natural log of x squared. And then e and l then cancel, and I'm left with this argument is equal to that argument. Okay. So no matter how you approach it, this argument is equal to that argument. Okay. Does everybody follow that? Okay. So we have x minus 2 times 2x minus 3 is equal to x squared. Arguments must be equal. Well, now we FOIL this on the left-hand side. So when we multiply first terms, we get 2x squared. When we multiply outer terms, we get minus 3x. When we multiply inner terms, we get minus 4x. When we multiply last terms, we get plus 6. And that has to equal x squared. Okay. So this is a quadratic equation in one variable. We know how to solve those. Okay. So we bring the x squared over to the left-hand side by subtraction. We have 2x squared minus x squared is 1x squared. Minus 3x minus 4x is minus 7x. We have plus 6, and that's equal to 0. Well, that factors on the left-hand side into x minus 6 times x minus 1. And so by the zero product property, either x minus 6 is equal to 0, or x minus 1 is equal to 0, which means x is equal to 6, or x is equal to 1. So it appears that we have two solutions to our original equation. Okay. But riddle me this, ladies and gentlemen. Can you take the log of 0? Is the log of 0 defined, or is it undefined?
The log base of 0?
Can you take the log of the number 0 in any base? Can you take the log of a negative number in any base? Right? That's what we learned. Right? So, the number 1, if I put that in for x in the original equation here, I have the natural log of 1 minus 2. Well, 1 minus 2 is equal to negative 1. The natural log of negative 1 is undefined. So x equals 1 does not work in our original equation. It is what we call an extraneous solution. It's a solution to this quadratic equation, but it's not a solution to our original equation. We created that extraneous solution when we used the product rule. Okay. So the only value of x that works in our original equation is x equals 6. Okay. So you have to check for extraneous solutions when you solve the quadratic equation. Any questions on that? All right, if you flip over to page 3, the solutions to those 4 problems are on video. Made the video last semester. So on Oaks, under exam 4 videos, there's a link called section 5.3, page 3 examples. Okay. So part of your homework assignment for tomorrow night is to watch that video, right? And fill out your handout for those 4 examples. Okay. I think the video might be 8 minutes long, or 13 minutes long, something like that. So you flip over to the last page, page 4. We're going to find a couple of inverse functions. And so you know about the inverse functions. So on the first one, we're given f of x is equal to e raised to the 3x minus 1 power plus 5. That's a 1-to-1 function. Find its inverse function. So there are 4 steps that you do every time in finding an inverse function. Right? We learned those back in 2.8, I think it was, when we studied inverse functions. Okay. Step number 1, replace f of x with y. Step number 2, switch x and y. Step number 3, solve for y. So in solving for y, right, we got to isolate y on one side of the equal sign. So we'll subtract 5 from both sides. We have x minus 5 is equal to e raised to the 3y minus 1 power. So y is in the exponent, right? So we have e raised to 3y minus 1. What gets rid of this e? What gets rid of the e? Yeah, property 3, right? The natural log function. So we take the natural log of both sides, and we have the natural log of x minus 5 is equal to the natural log of e raised to the 3y minus 1 power. Okay. X minus 5 is the argument into the natural log function on the left. E raised to the 3y minus 1 power is the argument into the natural log function on the right. So we just have the natural log of x minus 5 on the left. On the right, the natural log function and the natural exponential function, they cancel each other because they're inverse functions of each other. Right? And we're just left with the exponent 3y minus 1, right, by property 3. Now it's easy to solve. We add 1 to both sides. And we have 1, I'm gonna put the 1 in front of the natural log. So I don't think it's part of the argument going to the natural log. And now I divide both sides by 3, okay? And when I switch the two sides, I have y is equal to 1 plus the natural log of x minus 5 over 3. And then the last step is to replace y with inverse function notation. So the inverse function of this, of f of x, right, involving the natural exponential function, the inverse function, this is the inverse function involving the natural log function. Remember, the natural exponential function and the natural log function are inverse functions. So the function on the right, the inverse function on the right, involves the natural log function. And you know, when finding the domain of the natural log function, you set the argument greater than 0. We did that on prior. So the domain for the inverse function, you set the argument x minus 5 greater than 0, right? Because you can't take the natural log of 0 or a negative number. And when you solve for x, you get x is greater than 5. And in interval notation, that's parentheses 5 to infinity. So this is what goes in, right, in the blank, right, just right. This is the domain inequality. Well, our inverse function is actually just a transformation on the natural log function. Remember, the graph of the natural log function looks like this. Right, this is y equals the natural log of x. So we graph that. In your section 5.2 notes, right? Natural log of x. And the range, right, for the natural log of x is minus infinity to plus infinity. And so our inverse function here is just a transformation on this function. When we place x with x minus 5, right, it shifts the graph to the right 5 units, but doesn't affect the range. Okay? And when we dividing the natural log of x minus 5 by 3 is the same as multiplied by 1/3. That condenses it, right, by a factor of 1/3, which doesn't affect the range. And then when you add 1/3 to the function, right, it shifts it up 1/3 of a unit, which doesn't affect the range. So the range of this inverse function is the same as the range of the natural log of x, which is minus infinity to plus infinity. And so the range for our inverse function, right, is the same as the range of the natural log function, right? Minus infinity to plus infinity. This transformation on the natural log function does not affect the range. All right, so we'll do B tomorrow first thing. So I'll move out the homework to Wednesday night. Okay. The homework for this section will be due Wednesday night. Okay. So I'll see you tomorrow. Have a good day.